Hi everyone, welcome to my YouTube channel. I hope you all are doing extremely well. First of all, if you are new to this channel or if you haven't subscribed my channel till now, then guys do consider subscribing my channel. You can follow me on other platforms as well. The link is there in the description itself. So yes, we'll continue our 150 NEET code question series, right? So today's problem is top K frequent elements. So as usual, first of all, we'll be understanding the approaches, the logic, and yep, the code part as well. So let's get started with the problem statement now. The problem says, given an integer array nums and an integer k, return the k most frequent elements. You may return the answer in any order. So we are having an array nums and an integer k value has been given to us. So we have to return the k most frequent elements. So let's say k value is 2. So 2 most frequent elements, 3 most frequent elements likewise. And the order can be like, it's not that they have to be in the given order as if given in the original array. So order is something that you don't need to bother about. So let's say here we do have this example. So if you will check, so here 1 has occurred thrice, 2 has occurred twice, 3 has occurred once. So if someone asks you that, okay, what is the k values 2? So 2 most frequent elements in this array. So obviously 1 and 2, right? They would be 1 and 2. So that's what we're returning in the output. Likewise, in the next example, we are having just one element in the nums array and we have to return the one most because k value is 1. So one most frequent element. So what is that? 1. So that's what we are returning. So here are the constraints given and it is guaranteed that the answer is going to be unique. One follow-up has been added and obviously we will discuss about it. So the most basic approach of one thing that will definitely come to your mind, I should expect if you have solved the previous problems which we have covered in this series. So if you are someone is starting from this question, I would suggest that solve the previous problems that we have already discussed so that at least you can, by now you will be able to think, okay, what approach basically I can use, what logic I can build up, at least the brute force one, right? So that's what I'm expecting. So first, as if I was specifying here about the frequencies, right? That 1 has occurred thrice, 2 has occurred twice. So one thing that you can think of is that we need a hash map to store the frequencies of each element that has occurred in the nums. Hash map we have, right? So let's say in the hash map we have stored the entries. So 1 has occurred thrice, so we are having the frequency of the same. 2 has occurred twice, 3 has occurred once. Now, okay, so now you are having the frequency of each element with you. So how you can determine the k most, or let's say here k is 2, so 2 most frequent elements. So if I would just sort my hash map uh, on the basis of values, because values are going to tell you know that which is the frequency element. So I'm going to sort my hash map on the basis of values, and that also let's sort in descending order. So the entry which entry is going to be at the first place or at the first number, let me say in this way, obviously the entry which is having the highest frequency, that would be, so here the highest frequency, 1 is having the highest frequency, so that would be at the first place. Then at the second place we'll be having 2, and at the third place we'll be having 3, right? Now what do we need from this? Once our sorting part is done, we need just k most frequent, and that also the key, because key is the element, right? This is frequency we does not need, we have to return the k most frequent elements that is occurred in nums. So that are 1 and 2. So as if here we are returning an integer array, so we will store these two values in an integer array and we will return our answer, right? So this is the approach that I believe most of you must be able to think of. But if we are talking about the time complexity of this particular approach, so what it would be, you tell me. So what we are doing is, first we are creating a hash map, right? Storing the values, iterating over the elements. So this will take big of n time, this loop. Then post that, what we are doing is that we are sorting it. And for sorting the elements, what is the time complexity? N log n, right? So uh, overall time complexity, if I'm talking about, so that would be N log n, right? And here in the follow-up, they've specified that your algorithm's time complexity must be better than N log n. So this is the one approach you can think of, but yes, they are expecting something better than this, right? So that's what it is. So first let's understand the code of this approach, then obviously we will think if we can do something, any approach that we can use that would be something better than this one, right? So yeah, here you can see we have taken the map, we have stored, here we are just going through each element and we're putting the entries in the map, basically the frequency which is associated with each value, and you must be able to do these things, because we have already done pretty much questions about the same in the previous videos that we have covered. So make sure to watch those videos and then hop on to this one. Then what we are doing here is, so yeah, if you're not comfortable with Java, you won't be able to understand, but you got the thing, right? You got the logic that what exactly we have to do. We have to sort our hash map on the basis of its values in the descending order and just fetch k values out of it, and just take the keys, take those k keys and store them in an array, in an integer array, and return that array. So that's what we are doing here is, we have taken this as a stream. So map.entryset.stream, we are sorting it. Okay, we are just okay, we are just sorting this in, we are comparing the values and we are sorting them in descending order. That's what we have specified here, dot reverse order. And now we have already have this inbuilt method, so you can directly, like I have directly utilized this one. So we are because see, whatever the result we are getting, we are storing this in another hash map. So here we are limiting the entries till k, because I need just k entries only, and then converting this, collecting them into a map, right? This thing is not needed, right? And here providing the key and the value associated, right? So now we have our new hash map, which is top k, and which is having the top k most frequent elements entries, that is the key and the value. Key, that is the element, and value is the frequency, right? So now next step is that, so we'll be going through the, like we are just going through the keys of that hash map. So top k dot key set, we are going through each element and we are storing this in result. So we have used for the indexing purpose. So result I plus equal to element, we are just storing here, and at the end we are returning the result, right? So this is our first approach. Right? Now another approach is by using the, whenever such question comes up, I am not sure if you are guys aware with the heap or not. So what I'm thinking is that not to discuss the heap approach in this video, right? But yeah, just one thing, whenever you see questions like top k, top elements, closest, like this is a kind of, a kind of identification karna, like in what problems we can use heap. So in this problem also we can use heap, and we can solve this by using what? By using min heap, right? And obviously the time complexity would be better than what we are having right now. Right now we are having big of and log n. So if you will use heap, the time complexity would be big of and log k. Okay, but I am, as of now, I'm taking under this consideration that you guys don't know about heap, so I won't discuss that solution. But yeah, something, the solution that you will be able to understand. Okay, and obviously that would be better than that of this heap one also. So as of now, let me come. So now I'm going to talk about the optimized solution. So as of now, what we were doing is that we were having this hash map and everything, and then we were just sorting it. So now, can't we do in this way that we are having our hash map that is needed. We are having our hash map. Okay. Then one thing is for sure. That see, now what we can do, see here, if you will see k value that we do have, so that would be, k value would be in the range of 1 to the number of unique elements that we do have in the array. So, and how you will get the unique elements? We are having our hash map, so we can get it from the size of our hash map. So whatever entries are there. So for example, in this case, so 3 elements are the unique elements. So we can take the size, we will take an array, okay, and we will take the size of this as whatever the map size is, just do +1, because we are having 0 indexing, right? So 0 1 2 3. Okay, so this is our array. You will understand like why I'm doing in this way. So this is something that we are completely sure about. Okay, 0 1 2 3, 0 1 2 3 we do have. Now what we can do is that, instead of on each index, this is our index. So on, now let's do in this way that this thing hash map we already have. Okay, let me write here, because this is like, I'm just trying to deliver to you. So 1 3 2 2 3 1, right? So what we will take, we are having our hash map, right? We are having our hash map. So with 3, what is the what is the key we are having? With 3, what is the key we are having? So this 3, what we are going to do? We are going to, this would be our index. 3 would be our index. So we are saying at third index, put the value 1. At third index, put the value 1. Now, at second index, put the value 2. Put the value 2. Now, there could be a possibility that 3 has also occurred twice. I'm just saying, yeah, obviously it could be. So, this thing, this values we are taking this on, like, these values are acting as an index for us. They are acting as a for index for us. And why we are doing this is because if you will, this is clearly specified here that what would be the k size. K range would be in 1 to the number of unique elements in the array. Right? This is what gives us the indication that okay, we can think in this way, we can think in this direction. So here, next, whatever. So 3 can also occur twice, that is for sure. So 3 mapping also we have to do. 3 also, this 3 also we have to put on this index itself. 3 also we need. So what would be the data structure basically that we'll be using? Obviously there would be the elements which would be having the same frequencies. So we have to store them on that particular index. The frequency is something that we are taking as a what? As an index, right? So what will be the data structure that I'm asking to you? Array of list of integers. Array of list of integers that we'll be using. Okay. So yeah, that is our next approach, or the optimized approach, I would say. So what we are doing is that this is the result array that we have to return at the end, and the size is k. And here we are again the same thing, that we are preparing our hash map that is containing the frequencies of each element that has occurred in our nums array. Right now we are having our array of list of integers, so named as buckets, and the size would be nums dot length plus 1, because indexing doesn't start from 0, so that's what right. So here one thing, just I know you know it, but just I'm specifying it, that in the worst case, what could be the highest frequency? The highest frequency could be, see, if 1 has occurred every time, so 1 2 3 4 5 6, that would be the length of the array itself, right? The length of the array itself. मोर देन दैट, मतलब इससे ज्यादा तो कोई एलिमेंट अगर नहीं करेगा ना, मतलब साइज पे ही डिपेंड करेगा ना नम्स के, तभी तो हमने क्या किया. दैट्स व्हाई वी हैव टेकन एरे ऑफ लिस्ट ऑफ इंटीजर्स, एंड दैट्स व्हाट वी हैव, बिकॉज हमारा साइज रिड्यूस हो गया. फर्स्ट ऑफ ऑल साइज हमारा रिड्यूस हो गया, जो एरे हम यहाँ पे ले रहे हैं इसका साइज काफी हद तक रिड्यूस हो गया. एंड देन देखो, जब हमने ये अपनी पूरी प्रिपेयर कर ली एरे ऑफ लिस्ट ऑफ इंटीजर्स, नेक्स्ट स्टेप इज दैट you know it, that since we have taken the index as the frequency wala thing, right? You know it. So we will start iterating from iterating from the last, because whatever is the element at the last of our array that we have prepared, array of list of integers, that would have occurred, that would be the most frequent, the first frequent element, right? So here what would be that? 1. Then next 2. Then below that we have 3. So like that, right? So that is the thing. So here we are having buckets. Then we are going through the entries that we do have in our hash map. So first thing is that we are fetching out the frequency out of it, right? So first we are checking that if buckets frequency, if that is equal to null, because we are creating what? Array of list of integers. So we are just assigning buckets frequency equal to new array list. We are assigning a new array list over there on that frequency, and then on that particular index, we are adding that key. So let's say the first key was 1. So at third index frequency is, let's say this is 3. So at third index we are adding the key that is nothing but 1. In that array list we are adding 1. Similarly, next entry would come as 2, let's say. So likewise we are adding 2 at the index 2. Likewise, let's say next comes 3. So 3 next comes, okay, we are taking what? We are taking the frequency wala thing na. So next comes the frequency is 2. So at that specific index buckets frequency equal to null, that condition won't be true because we already have this thing, right? So at that particular index, we are just adding the key. So already there is one key, which is 2. So to that, we are just adding one more, that is 3. Also we are adding, right? So likewise it is. So we will prepare our array of list of integers. Then we have to do the iteration part. So as if I said, that would be from the end, because the element which is at the end would be the most frequent one. And we need just k entries, right? We just need k elements only. So that's why we are doing here is that I greater than equal to 0 and c value. So c we have initialized initially with the 0, and c value should be less than k, I minus minus. So here first we are checking that if could be a possibility, that buckets of I itself is null. So that's why we are checking if buckets of I not equal to null. Then we are digging in deeper. Why we are having the another loop? Because at a specific index there can be multiple elements also. There can be multiple elements also, right? So that's why we're doing for int num at a specific index buckets of I. So we are just storing the element in the result array. So resc++ equal to num. And here also we are just checking it that if at any specific point of time the c become equal to that of k, just break the loop, right? And we are at the end we are just returning the result array, res, right? Okay, so this is the optimized approach. And if I am asking you about the time complexity, so just see here, what would be the time complexity? What would be the time complexity of this approach? Should I tell you, or I should expect the answer from your end? You tell me the time complexity of this approach. If you have completed the whole problem, so I'm expecting that you will be at the end. So just let me know in the comment section what is the time complexity of this particular approach and space complexity as well, right? So yeah, thank you so much for watching this video, everyone. Bye bye, keep going, maintain the consistency, and if there is any feedback, I mean in terms of explanation or anything, just let me know in the comment section. Thank you, everyone. Bye bye.